Bailey with the Knox County Public Library Tutor Team, and I'm here today with another video math lesson covering kindergarten and first grade academic standards. We are covering number sense standards today, and as I've said in previous videos, it's important that you understand that the language of these academic standards may not completely be covered with fidelity in this video lesson, but they are standards that we are either covering skills that are going to be worked up to or that we are touching on throughout the lesson. If you are interested in additional academic grade level specific standards, you can visit the doe.in.gov website that's listed right here. Here are some tips that I've put together for parents if you are looking for ways to help your learner modify the lesson. So the purple dots represent the level of difficulty, and these suggestions are for learners who may not be quite ready to complete the whole lesson, and they're needing some practice on prerequisite skills before they are ready to complete the lesson with ease. Here are some tips that I have for parents who are noticing that their learners are doing pretty well with the video. Either it's a almost perfect fit for them. The two purple dots represent that this is, the level of difficulty of the video lesson is an easy, not easy, but a good fit for your learner. And so the suggestion that I have there is just be sure that your learner is participating with as much pausing or replaying as needed with the lesson. And then the last suggestion with the three purple dots are for learners who are doing very well with the video lesson to the point where they're ready to extend it and maybe looking for an added challenge. In the last few videos, we've talked a lot about addition number sentences and the different ways that they can work. We will be working our way up to talking about fact families. And these addition number sentences that are listed here are an example of a fact family that you can encourage your learner to practice if they are ready for that extra challenge. You will see this symbol when materials are needed during this video lesson. All right, mathematicians, it's time for us to dive in and have some fun with our math skills. I'm so glad that you're here with me today, and really quickly, I just want to go over with you the way that mathematicians look and sound. Okay, that light bulb symbol is our clue that we are doing something that involves the goal that we are working on. So good mathematicians really try to keep their goal in mind, not just before we do the lesson, but during the lesson and after the lesson. They use math tools. So the tools that we've been talking about a lot in the last few videos are 10 frames and number bonds. They stay organized by finding groups, such as groups of 5, and circling them. Another really important thing that we've been talking about in the last video was using time wisely. Good mathematicians use their time wisely by doing things like quick pictures. Instead of taking a long time to draw out a picture, we can just draw a quick picture with circles that are about the same size in a nice, neat row. And this one is so important to me that you understand that a good mathematician makes mistakes. If you make mistakes, I never ever want you to feel like, oh, I'm not good at math. Because good mathematicians make mistakes. Mistakes are proof that we are trying and proof that we are learning and practice makes progress, friends. So as long as you are trying your very best, even if you make a mistake, you are a good mathematician. And what's really important with making mistakes is that we take the time to notice them, not give up on ourselves, and keep trying. Good mathematicians use correct number formation. So here are some examples of all of the digits that we use in numbers and the correct way to start the number and form the number. Good mathematicians also review their mathematician vocabulary. So one of the vocabulary words that we have used a lot lately is number sentence, specifically addition number sentence, where we are adding the parts. So we have been working with addition number sentences that have two smaller parts that add together to equal a whole amount. We've also talked about how, as a number detective, it's also very important for us to look for those clue words. When we are reading number stories, there are clue words that are the same meaning as the math symbols that we use, such as the addition sign and the equal sign. The last two videos we talked about turnaround facts, otherwise known as flip-flop facts. So as long as you are using your parts, no matter which order you put your parts in, they are going to equal your whole amount. Now it's really important that you pay attention to what I just said. The parts can be flip-flopped. You can't just flip-flop any of the numbers in these addition number sentences because then they wouldn't be true. But if you flip-flop the two parts, no matter which way you put them, they will equal the whole amount. We've been building up our fact power. So these are facts that we've learned about and talked about, and we've noticed patterns like the turnaround fact pattern, or we also call that the flip-flop pattern. Even when you flip-flop the parts, the whole is the same. Also, we have been talking about how addition number sentences can begin with the whole amount and the equal sign. I know that this might look different from what you're used to seeing, but if you think about it, it is true that 6 is the same thing as 4 plus 2 more. So with the whole amount and the equal sign at the beginning of the addition number sentence, as long as the parts and the whole are the same, you can put the equal sign in front of the number sentence. If we try it out and we look at it this way, where we use our math tool, the 10 frame, to check our work, look, if we have 4 plus 2 more, it is the same thing as 6. Okay, 6 is the same thing or equal to 4 plus 2 more. Now here's an example of what I mean when I say you can't just rearrange any of the numbers. You have to stick with rearranging the smaller parts, because if you look here, if we add the whole amount to one of the parts, what it equals is not a number that was originally in our addition number sentence. So it is not true, or it's false, that 6 plus 2 more is 4. And we can check our work by looking at the 10 frame. 6 plus 2 more is 6, 7, 8. And that doesn't work because those are not the numbers that we are trying to use in our addition number sentence. Again, addition number sentences can have different looks, whether they start with the whole amount and the equal sign or end with the whole amount and equal sign. As long as you use the correct parts and the correct whole amount, you can have this type of number sentence. Checking our work, we can see why. And again, looking here, we can see that this is not true. So as we are working out our fact power, we are noticing more and more patterns to keep our eyes out for and things that are easy for us to get tripped up. So keeping an eye out for making sure that you are thinking about the parts and the whole amount will help you not make silly mistakes. We have been practicing so many facts, and your fact power is building stronger and stronger every day. Again, we can see here that if we turn around the parts or flip-flop the parts, we get the same whole amount. We can check to make sure that it is true that 6 is the same thing or equal to 5 plus 1 more. Or we can rearrange it where we say 5 plus 1 more is the same thing as 6. If we try where we just rearrange the numbers this way, 6 plus 1 more equals 5, that's false. It's not true because if you look, 6 plus 1 more is 6, 7. So when we count on 1 more than 6, we don't get 5, which we need to use those same 3 digits so that we are using the correct parts and whole amount to represent the addition number sentence. Friends, we've also talked a lot about being organized, and mathematicians are organized. We talked about how that's one of the ways that they look and sound if you are being a good mathematician. So here are some ways that we have stayed organized by grouping things together in a way that makes sense, using a 10 frame or a number bond, writing a number sentence, drawing a quick picture, or circling hidden parts. And we have talked about circling multiple hidden parts or finding groups of 5 to circle and then counting our leftovers. Circling groups of 5 is a very important tool to use to stay organized. Okay, and we talked about how mathematicians use their time wisely. So a quick drawing is very important. I know it's so fun to draw things like these cute puppies, but if we are using our time wisely, we need to draw quickly. So circles that are about the same size in nice neat rows, and these circles you'll notice that I have them grouped like a 10 frame. So I have the group of 5 that I found and circled, shown with the blank circles, and then the 2 left over shown as solid filled in circles. Our number bond is a tool that we will continue using in today's video lesson to build our fact power. So friends, like I said, it's very important as mathematicians to review our vocabulary, our strategies, our tools, and our math symbols before we get started. And here is all of our hard work. I want you to notice all of our hard work is building those muscles, our fact power muscles. And here are the patterns that we've noticed so far. So we're going to go ahead and move on to our lesson now that we have done a very good big warm-up. We're ready to go. We're conditioned and ready. Our muscles are warmed up. Today I am organizing my thinking using math tools so that I can build my fact power. Now that should sound familiar to you because that's what we've been working on in the last couple of videos. The goal is a little bit different though today. Our goal will be achieved when I describe parts in groups of 7. So we've been working with whole amounts of 5 and 6. Now we're working our way up to 7. All right, friends, we're ready for practice problem number 1. And let's take a look here. We have some police officers. Can you find 2 groups or hidden parts? Now here is the grouping that I noticed that we could do. And you might have a different idea and that's fine. But this time we're going to group these police officers by police officers with a dog versus police officers without a dog. So we're going to find 2 groups. Can you find the police officers that have a dog and the police officers who do not? That's how we're going to group this first practice problem. There were 2 police officers with dogs. And then we had 1, 2, 3, 4, 5 leftovers. So if we have 2 and 5 more, think about what our whole amount is. Go ahead and get your pencil and paper ready, and we're going to draw the math tool that we're going to be using today, which is our number bond. So when you're ready, go ahead and draw your circle. This will be the circle that is for your whole amount. If you need to pause and press play, go ahead and do that. The next part of our number bond is to draw that line out for our first and then the next line. And these lines will go out to be the part of the number bond that our parts will go into, our 2 smaller parts. There's the circle for the first part and the circle for the last part. So again, we've been working on addition number sentences that have 2 parts that work together to equal a whole amount. Now that you have your number bond, let's organize our thinking using the number bond. Do you remember how many police officers are there in all? Let's go back to that first picture. There they are. And we talked about how there were 2 police officers with a dog, and then there were 5 more without. So I'm going to start with that, the bigger of the 2 numbers. Okay, I want you to do this with me. Say 5, and then count on the 2 more that we have in addition to the 5. 5, 6, 7. So how many police officers do we have in all? Did you say 7? You are correct, because if we start with our bigger number, between 5 and 2, 5 is bigger. 5 and then 2 more. 6, 7, that is 7 police officers total. Now, I want you to think about how many police officers are there with a dog, and draw a quick picture. How many did we have with the dog again? Did you draw a quick picture showing 2? You are correct. Now, how many police officers are there without a dog? Can you draw a quick picture to show those police officers? I'm going to go back to the picture, and then you can answer this question. We know that there are 2 police officers with dogs. How many police officers are there without a dog? Press pause and then play when you're ready. Did you draw a quick picture showing that there were 5 police officers without a dog? If you did, that is correct. Let's fill in our number bond with numbers now. We know that there are 2 police officers with a dog. So that's our first part. And then we also know that there are 5 police officers without a dog. So here's our number bond with the pictures and then our completed number bond with the actual numbers. Can you create an addition number sentence using your number bond? Press pause and then play when you're ready. Yes, so here's an example of a correct number sentence that you could have written. You could have said 2 plus 5 equals 7 because we're adding our parts. Two police officers with a dog and then 5 police officers without a dog. If you created another addition number sentence, you could flip-flop those parts and you could say that there are 5 police officers without a dog and 2 with a dog, equaling a total of 7. That is correct as well because of the flip-flop pattern or the turnaround fact pattern. So here are the 4 different ways that those addition number sentences could look. We could add 3 plus 4 equals 7. We could flip-flop that to 4 plus 3 equals 7. And we could also make it so that the whole amount is coming at the beginning of the addition sentence with the equal sign, because it is true that 7 equals 3 plus 4 more. It's also true that 7 equals 4 plus 3 more. Okay, let's take a look at this same picture of police officers. And we're going to spy with our spy eyes a different set of groups, okay? Another way to say that is we're going to categorize. The first practice problem we did, we grouped or put the police officers in categories of police with dogs, and then we put the rest of them in a category of police officers without dogs. Can you find a different way to group these police officers? This time, how about we group the police officers on motorcycles versus police officers who are just standing? Okay, can you spy with your eyes how many police officers are on motorcycles versus how many are standing? Okay, here they are. There are 3 police officers on motorcycles, and there are 4 who are not on motorcycles or just standing. Let's draw another number bond. Go ahead and draw your circle, your big circle for your whole amount. If you need to pause and press play when you're ready. Draw your line out for the first part and your next line out for the second part, and then we're ready to draw the circle for our parts. Very good. Okay, when you're ready, we will move on. So let's organize our thinking with this number bond. How many police officers are there in all? Are there in all? All is A-L-L. I got excited there and put 3 L's, I guess. Going back to the picture, take a look. How many police officers are there in all? And I would like for you to be able to use your groups that we're talking about. So let's say 4, because we want to use our time wisely. And so we want to start with our number that is biggest. So out of 4 and 3, which one's biggest? 4. So let's say 4 and count on 3 more. 4, 5, 6, 7. So how many do we have in all? 7. We know that there are 7 police officers in all. How many police officers are there on a motorcycle? Can you draw a quick picture to show me that? Do you remember? How many police officers were on a motorcycle? We go back to that picture. Use your spy eyes. How many are on a motorcycle? Pause and press play when you're ready. You're drawing a quick picture on your number bond. That's right, there are 3 police officers on a motorcycle. Now, how many police officers are standing? Can you draw a quick picture to show how many are standing? Here's that picture again. Or you can think of it this way by counting on. If you know that there are 3 on motorcycles, how many do you have to keep counting on to get to 7? Say 3 and keep counting until you get to 7. 4, 5, 6, 7. How many did you count on? That's right, we had to count on 4 more to get a total of 7. Let's fill in our number bond with numbers. So we know there are 3 police officers on a motorcycle. And using our quick pictures, we know that there are 4 police officers who are standing. Okay, so here's our completed number bond. Can you create an addition number sentence using your number bond? So you've done the hard part, friends. You're just ready to fill in the parts. Use your number bond to identify your parts. Yes, so we could say that 3 plus 4 equals 7. There's another way we could write this. Can you create an additional addition number sentence? Very good. You could also say 4 plus 3 more equals 7. Just flip-flop those parts. And you still get your whole amount of 7. So here are the 4 different ways that we could write this addition number sentence. We could say 3 plus 4 equals 7. We could flip-flop those parts and say 4 plus 3 equals 7. We could also rearrange the addition number sentence so that the whole amount and the equal sign are at the beginning by saying that 7 is equal to 3 plus 4. Or 7 is equal to 4 plus 3. Notice that the whole amount never changes. It is always going to be 7. The only thing that we rearrange or flip-flop are the parts, or the way that we have the math symbols organized. Friends, we worked really hard today in continuing building our fact power by organizing our thinking using our math tools. And you rocked out on achieving your goal of describing parts in groups of 7. That was a lot of work and a lot of practice with number sentences that equal a whole amount of 7. So adding to what we already have built up on our fact power, patterns that we've noticed, any number plus 1 will always equal 1 more than itself, and facts that we have practiced so far are facts that have parts in groups of 5 and 6, and today we added to that by practicing parts in groups of 7. Now remember, good mathematicians think about their goal before, during, and after the lesson. So I hope that after this lesson, you are continuing to build on that fact power and practice the types of facts that we've already been working on and looking for those patterns, and that you continue in real life looking for these math skills that we've been practicing and these math facts. Friends, thank you so much for joining me today with the Knox County Public Library Tutor Team. And I would like to just remind you that these videos are available on our YouTube page for the KCPL Tutor Team, and the link is right here. And there are videos that are available for 2nd and 3rd grade academic standards and 4th and 5th grade academic standards from my good friends, Mrs. Worland and Mr. Frederick. And we would like you to know that these videos are for anyone, not just friends within our school corporation. Please share these with friends. Also, even though these are grade level specific standards that are being covered in these videos, it's also important to know that even a 3rd grader might benefit from some of these lessons, covering these standards to kind of try to fill any holes or gaps that are there, especially with so much time off of school. So these videos are here for you to help you, and I appreciate you so much for coming and practicing with me today, and I hope to see you next time.